Hello and welcome back to ELI 5 Physics. Today we are once again going to be talking about a more mathematical concept, so we're going to be using the other layout we used last time. So today we are going to be talking about integration. So integration is really the opposite of derivation, so it's like the subtraction for addition or the division for multiplication. So last time we used derivation to find the slope of a line at any given point. Well, integration, we're going to be taking that graph of slopes we found with derivation and be using it to find the original line. So integration, the basic premise is, say we had some graph that looks like this, and we're trying to figure out what the area under the curve was, because that'll tell us what the change was from this point to this point, which will give us essentially what our line was. Well, let's say this area under the curve, we don't really have a way to figure out what it is, but we do know how to figure out is what if we had a bunch of tiny rectangles that looked per se like this. And let's say we had an infinite number of those under there. Then we could figure out a pretty good estimation of our curve. So a good way to estimate it is by creating a number of rectangles, and those rectangles are either over or underestimated, depending on how many you put and where you start them from. So let's say all of these little rectangles have a width of dx and a height of y prime, right? Because this y prime was our slopes for the last time, so it's going to be our point on the slope graph. Well, we can say that this graph, let's say that this graph is something along the lines of, we can say that it's looking generally like a negative cube, quadratic, negative power to the fourth. So let's say we have x, negative x to the fourth plus 3x squared minus x. Let's say this was this graph, right? And we wanted to say what was the area under the curve from, per se, 0 to 5. Well, then we would say the integral from 0 to 5 of negative x to the fourth plus 3x squared minus x. But how do we solve this from here? Well, it's important to note a couple things about what we just wrote. So this is our integration symbol, right? It's saying what is the summation of the area under the curve. It's kind of an extended S and refers back to the sigma symbol, which stands for summation. So this is saying what is the sum, the area under the curve, from 0 to 5 for this equation in terms of x, which is why we have to put a dx at the end. So it's saying our y's times our x's from here to here. So you'll remember last time, for derivation, it was x to the n, and then when you derivated it, it became nx to the n minus 1. Well, this one's just working in reverse. So let's say we had x to the n again. This works exactly in the reverse of this, so when you integrate it, it becomes 1 over n plus 1 x to the n plus 1. We raise the power and then divide by that instead of multiplying and then losing the power. It's exactly the opposite of what we did last time. And then you have to add c. Remember from derivation that whenever we had a constant, it goes away because it's not a power of the thing you're deriving by. So when we're integrating, we have to add c, which is just any constant number, because we don't know where on the y-axis this graph is taking place. We only know what it's doing in the x. So to go back to our equation, negative x to the fourth becomes negative 1 over 5 x to the fifth, plus this becomes a 3, so it becomes x cubed, minus this becomes x to the second, so it becomes 1/2 of x to the second, plus c, because we don't know where that is. So then, and we're doing that from 0 to 5, right? So in order to figure out what it is from 0 to 5, we plug 5 into this whole equation, and we plug 0 into this whole equation, and we subtract them, because f of 5 minus f of 0 should tell us what's happening in between those. So we go negative 1/5 of 5 to the fifth plus 5 cubed minus 1/2 of 5 squared plus c, which is a constant, of course. minus negative 1/5 of 0 to the 5th plus 0 cubed minus 1/2 of 0 squared plus c. There's a couple things we can do right off the bat. First off, we can get rid of these c's because they're going to be the same constant, and c minus c is always going to be 0. So let's see. Negative 1/5 of 5 to the 5th is going to be the same as 5 to the 4th, which is 25 times 25, which is 625. So this is going to be 625 plus 5 cubed is 125 minus half of 5 squared, so it's going to be 12.5. So then this is 0, and this is 0, and this is 0. So we can just ignore everything past this minus sign. All this is ignorable now, because these c's canceled, and 0 times anything is just 0, and 0 plus anything is just going to be whatever you started with. So then this problem is going to give us 125 and 625 is 750 minus 12.5 is going to be 737.5. That's going to be the area under our curve here. So that's all we're going to be talking about today. Thank you.